Okay, next topic, finding the second solution using reduction of order. Okay, we will discuss the method of reduction of order which enables us to use one known solution y1 to find the second solution y2 of a linear homogeneous differential equation a x a2 xy double prime plus a1 xy prime plus a0 xy equals to 0. From the theorem before, y1 and y2 must be linearly independent and the quotient y2 over y1 is not a constant. Therefore, the quotient is written as y2 over y1 equals to v or y2 equals to v y1. The following are the steps to derive the formula of reduction of order. Okay, so how to derive the formula of reduction of order? Okay, first, rewrite the second order homogeneous equation in the form of y double prime plus pxy prime plus qxy equals to 0. So, first kita tulis dalam bentuk linear order homogeneous equation. Okay, next, differentiate equation 1.9 to find y prime and y double prime. Okay, so from 1.9 here, okay, we can differentiate. Okay, y 1.9 is y equals to y2 equals to v y1. Okay, here, so we find the first and second derivative. So it means that we need to differentiate. Okay, next, after we differentiate, substitute equation 1.1 and 1.12 and 1.9 into equation 1.10. Okay, so kita masukkan dalam ni. So kita dah dapat tadi y double prime and then y prime. This one, y prime and y. Okay, so we substitute into equation 1.10. Okay, so we get this equation. The expression y1 double prime p plus py prime plus qy y1 is equal to 0 because y1 is the solution of equation. Okay, so we get equation 1.13 and then substitute u equals to v prime and u prime equals to v double prime into equation 1.12 and solve the differential equation obtain. Okay, so we get this one after we substitute, so we get equation 1.14. Okay, next, integrate both sides of equation 1.14. So it means that you need to integrate this equation. So you get this solution. Okay, so substitute back u equals to v prime into equation 1.14. Okay, so you get equation 1.16. And then last one, integrate equation 1.16. So you integrate this equation. Okay, integrate this equation. Integrate v prime, you get v. And then integrate yang right hand side. So awak akan dapat bentuk ni. Okay, finally we get the formula of reduction of order. So awak akan dapat this formula. So sebenarnya formula ni lah yang penting kita akan gunakan. Okay, this one. Okay, sebenarnya yang step yang atas-atas tu sebenarnya dia just show macam mana nak dapatkan this formula. Tapi untuk chapter ni sebenarnya kita just gunakan formula ni. So kita nak gunakan y2 equals to y1 integrate exponent negative p x dx over y1 square dx. Okay, this sebenarnya kalau reduction of order, okay, so saya terangkan sebelum ni, untuk second order linear differential equation, okay, so dia akan bagi dalam bentuk yang ni, second derivative. So awak solve untuk dapatkan y, so dia akan ada two solution which are y1 and y2. So kita dah tengok tadi yang topik homogeneous. Okay, topik homogeneous. So awak akan ada kan dapat y1 and y2. Okay, so untuk reduction of order, apa maksud reduction of order? Kita menggunakan formula ni bila diberi salah satu. Kalau yang ni kita cari dua-dua kan, kita cari y1 and y2. But this one kita nak cari just diberi salah satu. Maknanya contoh kat sini dia dah bagi y1, so we need to find y2. So cara nak cari y2 maknanya kat sini lah, bila kita ada dua solution, dia dah bagi dah y1, so awak nak cari just y2. So bila nak cari y2, just use this formula. So formula ni kita panggil reduction of order. Okay, so equation 1.17 is used to find the second solution y2 of the second order linear differential equation when the first solution y1 is given. The following are steps to find the second solution y2. Okay, so first write the equation in the form. So mula-mula make sure equation awak dalam bentuk y double prime plus pxy plus qxy equals to 0, and then we need to identify ps. So make sure kat sini constant 1, and then we need to identify PS. Okay, next. Substitute PS and Y1 in the formula Y2 equals to Y1. So gantikan sebab kita dah identify PS, and then kita dah diberi Y1. So solve for Y2. So you get the second solution, which is Y2. Okay, example 1.7, the function y1 equals to 1 over x is one of the solutions of x square y double prime plus 3xy prime plus y equals to 0. Find the second solution, y2, and write down the general solution. Okay, so just apply je tadi. Okay, first kita tulis dulu dalam bentuk general form. Okay, so make sure kat sini, kalau general form yang ni, okay, x square y double prime plus 3xy prime plus y. So make sure depan ni mesti constant 1. So untuk jadikan dia constant 1, you need to divide by x square. Okay, bahagi dengan x square semua. So yang ni 3x, dia akan dapat 3 over x, sebab kita bahagi 3x over x square. So you get 3 over x y prime plus 1 over x square y. And then your px is 3 over x. So kita identify dulu nilai px. Okay, next, substitute px equals to 3 over x and y1 equals to 1 over x in the formula and solve for y. So yang ni dia perlukan kemahiran dalam integration. Okay, so daripada formula ni, sebenarnya kita just use this formula to get y2. Okay, y1 kita ganti dengan 1 over x, and then exponent negatif. Ni memang dalam formula ada negatif, and then substitute your px and then y1 square. So yang ni dah formula dia. Okay, integrate negative 3 over s. Okay, integrate dapat negative 3 ln s, and then yang ni negative 1 darab dengan 2 dapat negative 2. Okay, then this one, yang ni kita guna properties. Kalau e ln x dapat x. So kalau e ln x negative 3 dapat x negatif 3. So dari mana dapat negatif 3 ni? Bawa yang ni ke depan, ke atas ni. So dia akan jadi ln x negatif 3. So equals to x negatif 3. And then bawah ni x negatif 2. And then simplify dulu. X negatif 3 over x negatif 2 dapat 1 over x. So depan ni memang kekal 1 over x. And then just integrate this one. Integrate 1 over x, you get ln x. Since ada bawah ni ada x, so kat sini. So the general solution, okay, so the general solution of the given differential equation is, so cara nak tulis general solution, biasa soalan bila dia tanya general solution, yang ni kita just tahu yang ni adalah nilai untuk y2. So y1 dia dah bagi 1 over x. So kalau general solution, this one, maksudnya awak masukkan dalam formula C1Y1 plus C2Y2. So gantikan Y1, this one is Y1, and then this is your Y2. Gantikan, and then kekalkan C1 and C2. Kecuali dia ada initial value, initial condition, so just masukkan nanti nilai C1 and C2. Okay, so for exercise 1.3, so boleh cuba jawab yang ni. Dia dah bagi dah, in each problem a differential equation and one solution y1 are given. Apply the formula of reduction of order to find the second solution. So dia dah bagi equation, dia dah bagi y1. So just substitute dalam formula, and then make sure, ingat kalau kat sini ada 2x square, make sure jadikan dia 1. Yang ni pun sama, ada x. So kena divide dulu by x. Yang ni pun sama, 4x square. Yang ni pun x square plus 1. Yang ni x square. So make sure jadikan dia dalam bentuk yang ni jadikan dia dalam bentuk general form ni kan. Yang ni. Okay, so